Hello, everyone. My name is Joaquin Casina, and today I will be teaching you Chapter 1 of our intermediate microeconomics. It is preferences and indifferences curves. I know that it might sound a lot like a bunch of economic mumbo jumbo right now, but I promise you that this chapter is very interesting, and once you see how it connects to everyday decisions that we make, you'll understand it a lot more. Okay, first of all, why should we care? So before we get into theory, I want to start with a real-world example that the textbook uses to motivate this entire chapter. The US government offers tax credits to people who buy hybrid cars or electric cars, and the goal is simple: reduce fuel consumption and lower carbon emissions. Sounds like a solid plan, right? But here's the question economics actually ask. Is it the best policy choice? Could the government achieve the same goal more efficiently with a different policy? To even begin answering that, we need to understand how consumers make decisions. And that starts with understanding preferences and what they're willing to give up, how they trade one thing for another, and this is exactly what this chapter teaches us. Okay, so economists build all of consumer theory around three core assumptions about preferences. Think of these as the ground rules that every consumer is assumed to follow. So the first assumption is completeness. This means a consumer can always rank any two bundles of goods given options A and B. You either prefer A over B, B over A, or you're completely indifferent between the two. The key word here is always. There's no situation where you can just freeze up and say you literally cannot compare them. The second assumption is transitivity. This means preferences have to be logically consistent. If you prefer pizza over tacos, tacos over salad, then you must prefer pizza over salad. No going in circles. If your preferences went pizza over tacos, tacos over salad, but then salad over pizza, that would violate the transitivity and our model would just completely break down. The third assumption is more is better. If one bundle has at least as much of everything and more of at least one thing compared to another bundle, then you most probably would prefer it. This one seems pretty obvious, but it's a formal assumption that drives a lot of what we do in this chapter. Now, here's something that's very interesting. What happens when these assumptions fail? Imagine walking into a restaurant when the entire menu is written in a language that you just don't speak at all. You literally cannot rank the dishes whatsoever. Completeness fails, and our model can't predict your behavior. So our model works great most of the time, but not in every situation. The indifference curves. Now that we have our three assumptions, we can actually graph preferences. The tool we use is called an indifference curve. The definition is an indifference curve is a line that connects all bundles of goods that give a consumer exactly equal satisfaction. So a consumer is equally happy or indifferent between any 2 points sitting on the same curve. Look at the graph here. We have, let me move out the way. So look at the graph here. We have burritos on the x-axis and sandwiches on the y-axis. Point A might represent 5 burritos and 3 sandwiches per week. Another point on that same curve might be 2 burritos and 7 sandwiches. Completely different combinations, but the consumer is happy with either one. Now notice that there are multiple curves on this graph. Each curve represents at a different level of satisfaction, and here's the key part. Curves that are further away from the origin represent higher utility. More of both goods means you're better off, so a curve in the upper right of the graph is always better than one closer to the origin. Three properties of indifference curves. Indifference curves have three different important properties. And what I love about this is that each property ties directly back into one of our three assumptions. Property one, indifference curves are downward sloping. This means if you get more burritos moving to the right of the graph, you need fewer sandwiches to stay on the same curve. Why? Because of more is better. If the curve sloped down, or sloped upward, I mean, you'd have more of both goods at a higher point, which means you'd be better off, not equally well off. So an upward slope directly violates our more is better assumption. Property two, And difference curves never cross each other. This one trips up a lot of people, so let me just try to explain it a little carefully. If two curves cross at a point, you'd reach a logical contradiction. That crossing point would be on two different utility levels at the same time, which means the same bundle gives you two different levels of satisfaction simultaneously. That's pretty much impossible, and it violates both transitivity and more is better. Property 3. Indifference curves are bowed in toward the origin, which economists call convex. This comes from a fourth assumption that we add that consumers just love variety. Think about it this way. If you only had burritos and zero sandwiches, you'd be willing to give up a lot of burritos just to get one sandwich. But if you already have 10 sandwiches, you wouldn't give up much more than just one because that willingness to trade is exactly what creates the bowed-in shape. The marginal rate of substitution, or MRS. This is one of the most important concepts of this chapter, and it is the marginal rate of substitution. The MRS answers one specific question: how many units of one good is a consumer willing to give up to get one more of another good while staying equally happy, meaning staying on the same indifference curve. The formula is MRX equals delta Y divided by delta X. That's just the change in good Y over the change in good X. So here's an example from the textbook. A student named Luca has 5 burritos and 4 sandwiches per week. He would be willing to give up 2 burritos to get just one more sandwich. So his MRS equals -2 divided by 1, which equals -2. The reason it's negative is because it's a trade-off. You gain one thing, but you lose another. Now, here's the geometric interpretation, and this is really important. The MRS is literally the slope of the indifference curve at any given point. And as you move along the curve to the right, getting more burritos and fewer sandwiches, the slope gets flatter and flatter. That's what we call a diminishing MRS, and it's exactly what produces the Bowden shape from the last slide that we were talking about. Okay, let's look at two special cases that are really common and worth knowing. So the first one is called perfect complements. These are goods that consumers only want in fixed proportions together. The textbook example is AirPods and an iPhone. An extra pair of AirPods is completely useless if you don't have an iPhone, and an extra iPhone adds nothing if you don't have AirPods. You always want them together in a 1-to-1 ratio. So look at the graph. The indifference curves are L-shaped with right angles. Moving along the horizontal or vertical part of the L gives you zero extra satisfaction because you're only getting one more of one good without the other. The second is perfect substitutes. These are goods where 1 unit of X is just as good as 1 unit of Y, no matter what. The textbook example is salt. So Morton salt versus diamond crystal salt. For most people, a teaspoon of salt is exactly as good as a teaspoon of the other brand. So look at the graph. The indifference curves are perfectly straight diagonal lines because the rate at which you trade one for the other never changes. Standard preferences, the ones we've been drawing with the Bowden shape, fall right into the middle between these two extremes. Now, let's try to bring it all back with the tax car credit that we started with. We can model a consumer's decision using an indifference curve with where one axis is miles driven and the other axis is money available for everything else in their life. This is actually a really powerful setup because it lets us capture the trade-off between driving and all other consumption at the same time. We assume the curves are downward sloping because both driving and money are goods. We assume that they don't cross, and we assume that they're bowed in because most people want balance. They don't want to spend their entire income on driving, and they also don't never want to drive at all. So, now here's where it gets really interesting. A tax credit makes hybrid cars cheaper, which effectively means driving becomes more affordable. But does cheaper driving automatically mean people drive less and save fuel? I don't think so. In fact, consumers might respond by driving more because it's cheaper to drive per mile. This is actually a real phenomenon called the rebound effect. Understanding the shape of consumer preferences is what allows economists to predict whether the policy will actually achieve its goal or backfire. So let's bring everything back together. And here are the five big takeaways from chapter one. Number one, preferences are built on three core assumptions: completeness, transitivity, and more is better. Number two, we represent preferences graphically using indifference curves where every point on a single curve gives the consumer equal satisfaction. Number three, indifference curves have three properties. They slope downward, they never cross, and they bow inward toward the origin. Number four, the marginal rate of substitution, or MRS, is the slope of the indifference curve. It tells us exactly how much of one good a consumer is willing to trade for one more unit of another. And number five, perfect complements give us L-shaped curves. Perfect substitutes give us straight lines, and standard preferences fall right in between. These five concepts are the absolute foundation of everything that we're going to study this semester, and it all builds directly on top of what we covered today. So to wrap up, we started with real government policy questions, built up the theory, and ended with a set of tools that economists actually use to analyze consumer behavior in the real world. I hope that this helped you click with the information, and thank you for watching.